Welcome to Get Your FRQ On. This question is from 2011. It's question 6, and it is not calculator active. In the question stem, we're given a function f, which is defined as a piecewise function. And in part A, we are asked to show that f is continuous at x equals 0. So in order to show that f is continuous at x equals 0, we have to show that f meets the definition of continuous at x equals 0, right? Which means that a couple of things have to be true. F of 0 must exist, which when you look at the definition of f, it will. F does return a value when x is 0. It is in the domain. But this f of 0 must equal the limit of the function as x approaches 0 from the left and equal the limit of the function as x approaches 0 from the right. All right, so step by step, by definition of the function f, we can plug in 0 for x. F of 0 is 1 minus 2 times the sine of 0, which is just going to be 1 minus 0, which is 0. I'm sorry, 1. And then if I look at the limit as x approaches 0 from the left of 1 minus 2 sine of x, that is equal to 1. And the limit as x approaches 0 from the right of e to the negative 4x, that is also equal to 1. So f of 0 equals 1, and both limits equal 1, so we have a continuous function at x equals 0. In part B of this question, we are asked to express the derivative of f as a piecewise function for all x not equal to 0, and then to solve the equation f prime of x equals negative 3. So to find f prime of x as a piecewise function, we're just going to differentiate the two parts of f. All right, so for x not equal to 0, the derivative of f is going to be negative 2 times the cosine of x. For x less than 0, and negative 4 times e to the negative 4x for x greater than 0. And if I want to solve when this is equal to negative 3, I'm just going to take both parts. There could be a solution on either side, who knows. Negative 2 cosine x equals negative 3 would imply that cosine x is equal to 3 halves. Note that 3 halves is bigger than 1. That's outside the range of cosine x. So the cosine x part will not produce a solution here. The first half, there are no values of x that are less than 0 for which f prime of x is equal to negative 3. Okay. Are there any values of x greater than 0 where f prime of x is equal to negative 3? Well, to do that, we're going to set up a similar equation using the other half of f prime. And if I try to solve that, e to the negative 4x is equal to positive 3/4. Take the natural log of both sides. Negative 4x is the natural log of 3/4, which means x is negative 1/4 the natural log of 3/4. Okay, notice this question is not calculator active. You will not be able to use a calculator to figure out some decimal here. The expectation is you will solve for x and express it as an algebraic expression rather than a numeric one. So negative 1/4 the natural log of 3/4. There's a couple of different ways you could probably write that, but you would have to have that specific answer written somehow correctly. In part C of the question, we are asked to find the average value of f over the interval from negative 1 to 1. Now, an average value of a function that's defined in terms of an integral, that's going to be 1 over 1 minus negative 1 times the integral from negative 1 to 1 of f of x dx. So we have 1/2 the integral from negative 1 to 0 of 1 minus 2 sine of x dx plus the integral from 0 to 1 of e to the minus 4x dx. Okay. So finding an antiderivative for each of those, we have x plus 2 cosine x. We're going to have to evaluate that at 0 and negative 1. And the antiderivative of e to the minus 4x is 1/4 e to the negative 4x. We're going to have to evaluate that at 1 and 0. Actually, it's negative 1/4. Notice I moved the subtraction outside instead of leaving it as addition. All right, so I have to evaluate both of those expressions, find the difference, take half of that. All right, so if I do that, I get 1/2 of 0 plus 2 minus the -1 plus 2 cosine -1 for the first half, and then I have 1 over 4e to the 4th minus 1/4. Technically, that would be sufficient. You would not have to simplify this. If you did, you can simplify it a bit, but notice that there's no actual calculus left to do in the 1/2 times this thing, and that should be sufficient to earn the points if you're a little bit squeamish about having to simplify something like that and maybe not simplifying it correctly. Just keep in mind that once you've done all the calculus, there's no more variables to contend with, and it's just an algebraic or numeric expression. You can just leave it. It's probably going to be unpleasant for the reader to read, but they will do it, and if it's correct, you will get the points.